Every time you hear that hiss, you're witnessing the end of an extraordinary journey. That pressure cooker in your kitchen began as red rock buried beneath the tropical rainforest, traveled through furnaces hotter than lava, and survived pressures that would crush almost anything else. Today, we're following its complete journey from raw earth to your dinner table. Our story begins in massive bauxite mines in places like Guinea or Australia. This reddish-brown ore contains aluminum oxide, formed millions of years ago when volcanic rocks weathered under tropical heat and rain. Excavators moving 50 tons at a time extract the ore, which is then crushed and washed. But this is just dirt. The real transformation happens next. At the alumina refinery, the Bayer process takes over. Bauxite is mixed with caustic soda at 270 degrees Celsius and extreme pressure. The aluminum oxide dissolves, leaving pure white alumina powder. But we're still not at metal. That requires the Hall-Héroult process. In massive electrolytic cells, alumina dissolves in molten cryolite at 960 degrees. Then an electrical current of up to 300,000 amperes, that's 3,000 times what your house uses, literally rips the molecules apart. Pure molten aluminum, glowing at nearly 1,000 degrees, pools at the bottom. Here's the crazy part. Making 1 kilogram of aluminum uses enough electricity to power your refrigerator for a week. These glowing ingots cool into pure aluminum, ready for the next step. Pure aluminum is too soft for a pressure cooker, so it's melted again and mixed with manganese, copper, and magnesium to create an alloy. These additions make up only 1 to 5%, but transform the metal entirely. The alloy is cast into slabs and rolled repeatedly between massive steel rollers, going from inches thick to just millimeters. Each pass makes it stronger. At the factory, circular blanks are cut and transformed through deep drawing. A massive press forces the flat disc into a seamless pot in seconds. No seams means no weak points. The base is machined perfectly flat for even heating. Many have tri-ply construction, stainless steel, aluminum core, stainless steel, the best of both metals. The lid gets a precision groove for the silicone gasket, that rubber ring creating the pressure-tight seal. Now the genius part, the pressure regulator. As steam builds and pressure reaches 15 psi, the weight lifts and steam escapes with that characteristic hiss. A backup safety valve prevents any failures. Every cooker is tested under pressure before leaving the factory. So how does it work? Normally, water boils at 100 degrees Celsius, but sealed inside, trapped steam builds pressure, raising the boiling point to 120 degrees. Those extra 20 degrees change everything. Higher temperature means up to 70% faster cooking. A 3-hour pot roast? 45 minutes. The pressure forces moisture deep into food, making tough meat tender and cooking beans in a fraction of normal time. And because it's faster, it uses less energy. Multiple safety features, the regulator, safety valve, locking lid, and gasket, work together to make it incredibly safe despite the intense pressure. And now, after crossing continents, surviving temperatures hotter than lava, and withstanding hundreds of tons of pressure during manufacturing, it arrives in your kitchen. The gasket seals perfectly. The aluminum alloy pot that began as tropical ore holds your ingredients. The precision valve controls the pressure. Heat rises through the tri-ply base. Water becomes steam. Pressure builds. Then, that hiss, that familiar sound of dinner in record time. 45 minutes later, you open the lid to a meal that would have taken hours any other way. From a hole in the ground to your dinner table, from one of Earth's most energy-intensive processes to one of your most efficient cooking methods. The pressure cooker represents something remarkable. Humanity's ability to transform raw earth through chemistry,
physics, and engineering into something that makes life better. So next time you hear that hiss, remember you're not just cooking dinner. You're witnessing the end of an incredible journey, millions of years and thousands of miles in the making.